Hello students, today we are going to discuss JEE Mains 2026 Phase 1, 22nd January morning shift. Come on, let us discuss the first question. Consider the given central metal ion of low spin complexes and choose the correct increasing order of unpaired electrons. Manganese, that is Mn3+, chromium 3+, iron 3+, and cobalt 3+. So here, two key points they have given. The first key point, it is low spin complex. The other one, what they mentioned, it is unpaired electrons. So easily we can identify if we know the order and the atomic number. Easily we can identify. So in this scandium to zinc, if you know that atomic number and order, it will be easy to identify the increasing order. Okay. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Right. Now here atomic number what it is? Here 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Right now here, what are the ions they mentioned? Cr3 plus, Mn3 plus, Fe3 plus, and CO3 plus. So 3 electrons loses from each element. That's all. Okay, easily we can identify. Chromium 24, no? So here argon. So argon it is 4s1, 3d5. So 3 electrons losing. Okay, so 3 electrons it loses means, so here how many electrons remaining when you are going for ion stage? 3 plus, right? So argon 3d 3, right? So 3d3 means 3d3. Okay, I'll draw that orbitals, 5 orbitals, no? So 3d5. So 1 2 3 4 and 5. Okay, now here 1 2 3, last two low spin complexes. So how many unpaired electrons? Here actually 3 unpaired electrons. 3 unpaired electrons. And the same way manganese. Manganese what it is? 25 manganese. So the same argon 3D. Oh, okay. 4s2 3d5. No. So 4s2 3d5. Okay. Now 4s2 3d5 is Mn2 plus Mn3 plus, right? Mn3 plus. So that means here argon. Here how many? 3d4. So when you're drawing that electronic configuration here, 4 unpaired electrons will be coming. How many? Okay, so here last two you just leave because it is low spin complexes. So here how many? 4 and 4, 3d4 now. So 1 2 3 and 4, right? So that means how many unpaired electrons? 2 unpaired electrons are there, sir. 2 unpaired. Got it? 2 unpaired electrons. How did you get? Last two, it is D2 complexes, no low spin complexes. Okay, so that is the reason. Okay, now the same way cobalt and iron and cobalt. Iron, how many? It is Fe26. So here the same thing, argon 4s2 3d6. So here minus 3 electrons, right? So that means here argon Fe3 plus, argon 3d5. So argon 3d5 means what it is? Argon 3d5. So when you are drawing that electronic configuration, 1 2 3 4 and 5. So here last two you just leave it. So that 5 means 1 2 3 4 and 5. So 1 unpaired electron. 1 unpaired electron. So easily for you to understand, I have drawn a clear idea for you. So now cobalt, it is 27. See last one. So 27 cobalt. So here what it is? Argon 4s2 3d7. So 3 electrons. So leave it. Okay, so cobalt it is CO3 plus. So CO3 plus means what it is? Here argon 3d, what it is? 6. So 3d6 means when you are drawing electronic configuration. So 1 2 3 4 5, right? Okay, now here last two orbitals, you just leave it low spin complexes. 1 2 3 4 5 6. So that means no unpaired electrons. No unpaired electrons. So from here only you can identify what it is. 3210. So 3210, what it is? According to that, first one 3 unpaired electrons, 2 unpaired electrons, and the next one 1 unpaired electron and no unpaired electron. So in that way, first one what it is? First, according to that option here, first one chromium. Chromium, how many unpaired electrons? Chromium, it is actually 3 unpaired electrons. Chromium, it is 3 unpaired electrons. Manganese, it is 2 unpaired electrons. And iron, it is 1 unpaired electrons. And cobalt, it is 0 unpaired electron. 3, 2, 1, 0. So naturally, greater and smaller and 0. So increasing order 0, 1, 2, 3. So option 1 only, it is exactly correct. I hope you got the clarity. How do we identify? See, that is what I just mentioned. Chromium, manganese, iron, cobalt. So easily we can identify. So this is first one, what it is? Cobalt. Next one iron, next one manganese, and then chromium. So it is increasing order. From this also you can identify unpaired electrons from right to left, it is increasing. So you can utilize this idea for other purpose also, like what it is, unpaired electrons, low spin complexes, from right to left it is increasing. In that way also you can identify. According to this, 3 plus electrons only, 3 plus ions, sorry, Fe3 plus or CO3 plus, the same thing, you can follow this. Okay, this step. I hope you got the clarity. How do we identify? Come on, let us go to the next question. The next question, match the following and choose the correct option. List 1 and 2, so we can identify very easily. Here, this is actually AgNH3. Twice, this is ammoniacal silver nitrate, right? So this is tolerance reagent. Okay, so this is tolerance reagent, very simple. And zinc amalgam with HCl, it is Clemenson's reduction. And the next one, what it is, hydrazine with KOH, that is Wolff-Kishner reduction. And Cu2 plus OH minus, this is actually Fehling solution. Okay, D option, D, it is first one. Yeah, I just mentioned here only. So this is first one, and this is Wolff-Kishner, it is fourth one. And next one, what it is, zinc amalgam, it is second one. And first one, what it is, ammoniacal silver nitrate, it is tolerance reagent. So 3. Right. So 3, 2, 4, 1. 3, 2, 4, 1. Okay, so this is option 3 only, it is correct. See, this is very interesting. Tolerance reagent, what purpose we are using? To identify aldehyde. And Clemenson's reduction and Wolff-Kishner reduction, both convert carbonyl compounds into alkane. And this is Clemenson's reduction, it is an acidic medium. And Wolff-Kishner reduction, it's a basic medium. And this is Fehling solution also to identify aldehyde. Right, I hope you got that clarity. Very interesting question and simple question also. Right, this will help you for the board also, because board also you may get such kind of question. Come on, let us go to the next given below. At 25 degrees Celsius. 25 degrees Celsius, it has mentioned that temperature. And A2, reversible 2A. A2, it is a reactant, and 2A, it is a product. Find ln Kp. So the given delta G naught formation A equal to, value they have given, it is minus 50.384 kilojoule per mole. And the same way, delta G naught formation A2 equal to minus 100 kilojoule per mole. So this is actually, this is a product, right? 2A, no, A, it is a product, and A2, it is a reactant. Now find that ln Kp. So before finding that ln Kp, let us find the formula for that reaction, right? What is that formula for the G naught formation of reaction? Delta G naught formation of the reaction equal to summation of delta G naught formation of product minus delta G naught summation of delta G naught formation of reactant. That is reactant minus product. That's all. Okay, now let us apply the value. Delta G naught formation of reaction. A reaction equal to, here what it is, moles also we have to identify. This is 2A, right? So minus, that is product minus reactant, no. So minus, here minus 50.384 kilojoule per mole. Minus, here what it is, 100 kilojoule per mole. Right. So that means here what it is. So when we are calculating this, we'll get what it is, 2 into these two. So minus into minus plus, you will get, right. So that means minus 0.768 kilojoule. Mole inverse will be cancelled, right? So kilojoule you are getting. Okay, now ln Kp. So ln Kp, how do we identify? Delta G naught equal to minus RT ln Kp. So ln Kp only we have to identify. So ln Kp, just we bring it out, ln Kp. Okay, so ln Kp equal to delta G naught divided by what it is? RT. So R it is 8.3 and the T it is actually what it is temperature 298 Kelvin, 25 degrees Celsius. No, so 298 Kelvin. Delta G naught, just now we found that this is delta G naught. Delta G naught formation of reaction. Just now we found this is the delta G naught. Okay. Delta G naught formation just now we found now. Okay, delta G naught reaction equal to product minus reaction. So product minus reaction, we applied the value. So we are getting that value. This is G naught and RT, R it is 8.3 and T it is temperature 298 Kelvin and kilojoule it has mentioned. So kilojoule means kilo it is 1000. So let us apply the value. So ln Kp equal to 0.768 into 1000. 1000 for what purpose? Kilojoule, right? So 1000 divided by 8.3 into 298 Kelvin, right? So you will get what it is when you calculating. You will get 0.31. So 0.31 it is what it is ln Kp. I hope you got that clarity. How do we get that ln Kp? So this is just the formula, just applying. When you look at that question, you just observe that question, read twice or thrice. So you will come to know that clarity what they are asking. It's very simple. You just understand the concept and according to that you just apply. That's all. So what is the correct option? The correct option it is 0.131. It is a value. I hope you got the clarity of this question. I think there is options they did not provide. So this is the value, right? Come on, let us go to the next question. The next question, which of the following is the correct order of the reactivity of given nucleophiles when treated with CH3Br in methanol oil, right? Okay, now this is actually SN2 mechanism, right? This is SN2 mechanism. So this part, what they have given, F minus I minus CH, C2H5O minus C6H5O minus, that is phenoxide, ethoxide, F minus I minus, that is halogen. So F minus and I minus, that is when we are considering F minus, it is smaller the size, and I minus, it is a larger the size. So here nucleophilicity, the reactivity of nucleophilicity will be increasing on the size of the anion. So I minus increases the nucleophilicity reactivity comparatively fluorine. So here this is I minus is greater than F minus. Now in that between they have given ethoxide and phenoxide. Ethoxide actually what it is a strong base comparatively phenoxide. Right. Now in that phenoxide what it is there, here resonance takes place, right? Resonance takes place right now. Here this is phenoxide, no? O minus means so automatically the transfer of electron, and here so delocalization of the reaction takes place. So delocalization takes place here only. So nucleophilicity of the reactivity will be decreasing when we are comparing with that C2H5O minus. So that means I minus will be the larger, nucleophilicity will be higher in that I minus, and then next one C2H5O minus, then after C6H5O minus, and the last one F minus. So this is the way we can give the order of the reactivity of nucleophile. So according to this, I minus, C2H5O minus, C6H5O minus, and F minus. So this is the one we can give that option. I hope you got the clarity why that option one it is correct, because here F minus, I minus, it is completely based on the size of the anion. Then C2H5O minus, C6H5O minus, C2H5O minus, it is a strong base comparatively, C6H5O minus. Why? Because C6H5O minus, it does not come in that point, because here delocalization of that electron takes place. Here what it is? Resonance, mainly we can say resonance takes place. I hope you got the clarity. Come on, let's go to the next question. Reactivity of following on the basis of SN1 mechanism. Here SN1 mechanism, we are talking about SN1 mechanism means it is tertiary, secondary, primary, and methyl. So this is the way we can bring it out. So mesomeric of 3 phenyl groups. So this point, let it be number 1. And the second one, this is 9 alpha hydrogen, it is available. So this is the second one. And the next one, here bridgehead carbon is available. So in that bridgehead carbon, this is 1 and this is 2. So according to this, here this is bigger than this. Why? Actually the second one, bridgehead carbon, it is actually very less stable comparatively first one due to very high strain, right? Now in that point, according to that, so this is fourth one, it's greater than third one, it's greater than first one, it's greater than second one, right? So this is the way we can bring that option. So 4 3 1 2 4 3 1 2 4 3 1 2. So option 1 is the correct option. Hope you got the clarity. Come on, let's go to the next one. Given below are two statements. Statement 1 says HX bond length is higher in HCl than HF. So HCl and HF, it is regarding about groups. So from top to bottom, group in the halogen point that we have to consider. The second point, the lowest boiling point in hydride of group 15 element is having covalency 4. Actually, covalency, it is 3 only, it is not 4. Okay. Okay, come on, let us check. I just to bring that idea for you to remember, as I mentioned in the first point, what it has mentioned, higher in that bond length is higher in HCl than HF. So when we are talking about group, so here in that group, what it has mentioned, so atomic size increases from top to bottom. See, 9, that is 17, so 35. Iodine 53. So as down the group, atomic size it's increasing. So naturally, bond length also will be increasing. So atomic size increases down the periodic table. So that is actually regarding bond length also will be increasing. So in that way speaking here, the another point, I just to bring that idea for you to remember. So this point here actually HF, fluorine, chlorine, bromine, iodine, as I mentioned in the group, atomic sizes increases naturally. Bond length also will be increasing according to this picture. I hope you understand through this picture along with the proof. Okay, HX bond becomes longer and weaker with increasing the size of the halogen. So HF bond and HCl bond, HBr bond, HI bond. So this is 3, no, 2, 3, 4, 5. As the atomic sizes increases, so bond length also will be increasing. Even that bond length, as I mentioned here, I hope this you can understand along with this picture, right? I hope. The next point, what it has mentioned, the next point, lowest boiling point in hydride of group 15 element is having covalency 4. Actually, the covalency, it is actually 3 only. So here, I just to bring that idea for you. Group 15 bismuth hydride BiH3, because it lacks significant intermolecular hydrogen bonding and has weaker van der Waals forces compared to heavier hydrides. It exhibits covalency with a high degree of sp3 hybridization and a low polarity of pH. Bond contributes to its low boiling point. See here, I just to bring that idea, lowest boiling point phosphine, reason lack of hydrogen bonding and weak intermolecular forces. So these are the two main points. What are those two main points? Lack of hydrogen bonding and weak intermolecular forces. So the boiling point, ammonia, it's greater than antimony hydride, that is SbH3, antimony hydride. It's greater than arsenic, AsH3. It's greater than phosphine, PH3. So this is 15th group element. No, so this is actually very lowest boiling point. Why? Because these two reasons, hydrogen bonding, lack of hydrogen bonding, and intermolecular forces of attraction. So phosphine covalency of molecule, actually it is 3 only, not 4. It has mentioned 4. So option 2, it is, that means statement 2, it is incorrect. Statement 1, it is correct. Actually, as we have seen through the proof, I hope you can understand this point, those two statements also. If you have that statement proof, no, very easily we can understand. That's what I just brought that idea of that proof. I hope you understand this point. So which is the correct answer? So first statement, it is the correct one. First statement, it is the correct one. Second statement, it is wrong. Actually, the covalency of 15th group element, it is 3 only, not 4. Right? You know where it will come 4. You know very well, right? Yes, exactly true. That is carbon and its family, right? Okay, come on. Which is the correct answer? Statement 1 is correct. Statement 2 is incorrect. So the option, it is 3. I hope you got the clarity. Come on, let us go to the next question. A compound A with molecular formula C9H11 NO. So C9H11 NO reacts with the bromine NaOH to give X. X on reaction with NaNO2 in HCl, dilute HCl, it gives compound Y. When Y is treated with CuCN followed by hydrolysis, it gives Z. And the compound A on hydrolysis also gives compound Z. Identify the compound A. Right now, this is actually puzzle like the question. Now C9H11NO. So C9H11NO. So this is a amide. NO2, it is a nitro compound. NO, it is an amide compound, right? So C double bond O, NH2. So NO, it is an amide compound only. So amide compound, when it reacts with Br2NaOH, bromamide, Hoffman's bromamide degradation, that point you can bring it. And this reaction, when it reacts with NaNO2 dilute HCl, this is diazotization. So diazotization, diazonium chloride, you can get it. When the diazonium chloride treated with the CuCN followed by hydrolysis, compound Z, it is diazonium chloride when it reacts with the CuCN, it is a Sand-Meyers reaction, right? Sand-Meyers reaction that is followed by hydrolysis. You will be getting hydrolysis means you will be getting carboxylic acid. See, the compound Z might be carboxylic acid. Then compound A directly you can go for hydrolysis. You will get that compound Z. So that means let us check carboxylic acid only the final answer. Let us check which compound might be that A. Now here actually first thing it is C9H11NO. So that means carbon 6 it is there in that benzene. 7, 8, 9. Yes, carbon it is 9, but a hydrogen C6H5. Right. So C6H6 benzene. One hydrogen replaces this. So C6H5, H5, 6, 7, 8, 9, 10, 11. So that means 11 what it is. Hydrogen is available, but still CONH. CONH means, let us check the other one. NO it is there. So 5, 6, 7, 8, 9, 10, 11. But whereas here C6, carbon 6 it is there. 7, 8, 9, hydrogen. This is 4, 5, 5 plus 6, 11. Hydrogen 11 it is there. And this one, carbon 6, 7, 8, 9. Whereas here it is actually hydrogen 5, 4, 5, 6, 7, 8, 9, 10, 11. Yes, this also it is available. Of course, this also that 6, 7, 8, 9. Whereas hydrogen here 5, 4, 6, 7, 8, 9, 10, 11, 12. Okay, let us check with that because bromamide, that is Hoffman's bromamide degradation. Okay, let us check with the compound C, that means the third. Let us check with that because here bromamide it is coming now. So C double bond O, here NH2. So Hoffman's bromamide degradation, it is Br2 NaOH. So when you are going for this reaction, you will be getting what it is. You'll be getting aniline formation along with CH3, CH2, CH3. Right. Now here, this is compound C, right? So CH2, CH3. Right. I will tell you that reason later. Now this is C, that means option 3. Let us check. That is hit and trial method only. Okay. Now here what it is? NH2. So NH2 you'll be getting here CH2, CH2, CH3. Right. Now, this is diazonium chloride. Diazonium chloride, when we go for it, NaNO2. NaNO2 bar HCl. So, you'll be getting what it is? Diazonium chloride along with that. Right. So, diazonium chloride. So, diazonium chloride here, this is the way we can bring it that point. So, this is N2Cl, N2 plus Cl minus. So diazonium chloride here that it will not affect this point, ethyl group, right? CH2, CH3. Right now, after that, this one which is reacting with the Sand-Meyers reaction, right? CuCN, CuCN hydrolysis, H3O plus. So what you will be getting here actually carboxylic acid. Okay, so as you are going for this reaction, you will be getting what it is carboxylic acid as I mentioned. So this will not be affected. CH2, CH3. I've told you know why I have taken this third point. This is a third compound I have taken. No, so this is the reason. So other than that, compound 1 and 2, 4. Compound 1, actually CH2, CH3, it is not available over here. Okay, so even if it is, so directly it will be, what it is, completely, it will go away while the reaction takes place with that diazotization. Whereas this reaction BR2 it will be actually degradation. One carbon will be reduced, whereas here two carbons are available. So this carbon it is actually two carbons are available. No, so that means this point it will be ho gaya. So that here also the same. Now methyl group it is there, here CH3. So which carbon meta directing group it is not possible. So this will not be possible because this is Hoffman's degradation. Hoffman's degradation means one carbon will be releasing out. So that is the reason I have taken compound C. Right now here also the same. Here CH2, CH3, here methyl group. Here also two carbons are available. So that means which carbon we are going to leave. But here what we are taken this point. So here this carbon completely go away. So that means this NH2 will be attached over here. So that is the reason I have taken that compound 3. Okay, I hope you got the clarity. Okay, now the compound A directly on hydrolysis, compound C, I mean compound Z. Okay, that means here that compound A directly on hydrolysis, this is C double bond O NH2. This is CH2 CH3, right? So directly on hydrolysis, H3O plus. So this is actually directly on hydrolysis. Now H plus CO H OH. Now that means here hydrogen will be attached, so that ammonia will be going away, and then OH, if it is combined, you will get COOH, right? COOH. So of course you will be getting the same as we mentioned, COOH, and here CH2 CH3, right? I hope you got the clarity. So this is the compound A and this is the compound Z. Right. Now this is the compound Z. That means compound 3 only it is possible. I have given that idea about why we are not selecting compound 1, 2 and 4 and all. Right. So this is the compound X, and next to that compound what it is, Y. Y, this is the compound Y. This is the compound Y, and this is the compound Z, and this is the compound A, and this is the compound Z. Both are similar. All right. I hope you got the clarity why I have selected 3 and why can't I select 1, 2 and 4. I hope you got the clarity. Yes. Come on, let us check the other question. Now the option it is 3 only. See, this kind of question and all, really it is puzzle. If you know all the ideas, concept and naming reactions, if you are in fingertips, you are able to identify such kind of question, you will be getting very interesting questions, such kind of these questions and all. Yes, come on, let's go to the next question. One more point also I would like to mention. This is a amide group, right? So amide group directly converted to carboxylic acid in the presence of H3O plus. That is actually a concept, basic concept, right? Where amide can be converted to carboxylic acid through hydrolysis. That is a basic concept. That is what I have starting also I mentioned. Like A compound directly can converted into Z. So that is through hydrolysis. That means amide can be converted to hydrolysis, converted to carboxylic acid through hydrolysis. This happens only for this compound, right? That is what I just mentioned. Let us check the next question. Which of the following statement is correct regarding the nature and the directive influence of nitro group? See, nitro group, it is actually electron withdrawing group, electronegativity more, right? Electron withdrawing group. In nitrobenzene, okay, nitrobenzene, just let me show you that point of nitrobenzene, right? NO2. So, which is the correct option according to this statement? It is an activating group and ortho para director. Naturally, this is totally wrong. This is a meta directing group. Nitro group, actually, it is a meta directing group. Why? Because here that deactivating, see, due to that delocalization of electron, so you will get that negative charge here, negative charge here, negative charge. So naturally, ortho and para directing group, it is deactivating due to that what it is, it reduces the electron density. So ortho para directing group, which will not be possible, it will be meta directing group. The second point, so first point it is wrong, the second point it is deactivating group and ortho para director. No, ortho para director, it is totally wrong. Deactivating group, yes, I agree for it, deactivating group, but it is ortho para, no, what it is, director, it is wrong. Right, now next one, deactivating group. Yes, it is correct. Meta director. Yes, exactly. It is true. Deactivating group, because it is what it is. Electron withdrawing group. This is deactivating group only. And the next one, what it is? Electrophilic addition, substitution. Sorry, electrophilic substitution reaction. Electrophilic substitution. Electrophilic substitution reaction. Substitution reaction. Right, now here it is an activating group and meta director. What activating or activating, which will not be correct, it is a deactivating group only. Meta director, it is correct. So which is the correct option? Option 3. So first and foremost, a nitro group, it is a electron withdrawing group, and this is actually what it is, strong minus I and minus M. This is strong minus I and minus M group. Electrophilic substitution reaction, it is there. And NO2 group, generally NO2 group, it is a meta directing group. Why it is a meta directing group? It is destabilizing in ortho and para. Why I mentioned destabilizing? Due to the delocalization of electron density. So due to that electron density, that is actually deactivating due to reduces the electron density. So naturally it is a meta directing group only. So I hope you got the clarity. All these points what I mentioned, it is yes. Come on, let's go to the next question. Consider the following sequence of reaction and identify A, B, C respectively. This also like puzzle question only, but it is very easy. Like as we mentioned, this is aniline combined with NaNO2HCl diazonium diazotization. So this compound aniline can converted into diazonium chloride through diazotization, NaNO2 nitrous acid, right? So NaNO2 HCl. So you will be getting diazonium chloride. Diazonium chloride, when it reacts with H3PO2, so here you will get benzene, because diazonium chloride can be converted through here H3PO2. So naturally you will get benzene. Benzene can react with what it is, bromine, FeBr3, so ferric bromide. So you will get bromobenzene, right? Come on, let us check with the reaction. So this is first one diazonium chloride, second one C6H6, and third one bromine, that is bromobenzene. Right now, let us check with that reaction. So here, this point, here what it is, first one aniline, right? Aniline NH2. NH2 combined with NaNO2 or HCl, right? Dilute HCl. So you'll be getting what it is, diazonium chloride. Here what use that? Here N2 plus Cl minus, diazonium chloride. Okay, so diazonium chloride, when it reacts with H3PO2, right? H3, H3PO2. So you will be getting what it is, benzene, PO2 or PO3, what it has mentioned in the question. Here PO2 only it is mentioned. Okay, that is what I just. Okay, so here you will be getting benzene only, because here H3PO2, so naturally you will be getting benzene. Then after that, these are all concepts. That is what I just to bring that idea for you, like mind map, no? So you will be remembering. This is diazonium chloride. When it reacts with what it is, hydrolysis, you'll get phenol and all these things, CuCN and H3PO2. So you will get benzene. So this reaction only, I just to bring it to your idea. See, generally mind map and the tricks, so tips and all, easily you can remember. Like always, mind maps helps us to remember many points. Yes, that is one way of learning and keeping in our mind memory power to increase. Okay, now next one, what it is, Br2. Br2, Br2 and FeBr3, ferric bromide. So you'll be getting bromobenzene, C6H5. Br. So this is bromobenzene, Br. Right. So this is the way you can get. So which are the correct option? Diazonium chloride and benzene and bromobenzene. Option A, it is diazonium chloride. Option B, benzene. Option C, what it is? Benzene bromide. Right, bromobenzene, right? So option 2, it's a correct option. This is nitrobenzene. No, it is not possible. Phenol, no, it is not possible. And this is chlorobenzene. How come it is possible? See, NaNO2 and HCl, it is 100% diazotization reaction. Please remember it that way at least. Br2, how you will get Br2? So this will not be possible. So this is that second option only. It is the correct option. And please remember all these points. If you are having in your notes or something, please take down those hints and all such kind of thing. Okay, like what to say, formula handbook like you're keeping now for physics and maths, for chemistry also, for organic, such kind of thing you please remember. Come on, let's go to the next question. Next question. In the following reaction sequence, identify the following compound. Right now here PQR. So this is phenol. Phenol combined with the sodium hydroxide. This also like puzzle. It's really interesting. Organic chemistry, it is so easy. Than physical and inorganic. Like inorganic also. Okay. Physical chemistry, there are so many questions they have given in this point. This JE Mains 2000 phase 1, 22nd of January. I think second day it was little bit what to say, moderate to higher level comparatively yesterday's question. Right now in the following reaction sequence, so this is phenol combined with the sodium hydroxide, sodium phenoxide you'll be getting. Sodium phenoxide combined with carbon dioxide, you will be getting carboxylic acid. Again it reacts with H plus, that is which is reacts with HCl or H2SO for like acid. If it combined with acid, so you'll be getting, it is actually salicylic acid. It's 100% naming reaction. You know what is that naming reaction? Salicylic acid. How do we get it from phenol? So this is a Kolb's reaction, right? I hope you got that idea. How do we get that? How do we remember Kolb's reaction? Kolb's reaction, right? So Kolb's reaction. Come on, let us write and show for you to remember. Right. Okay. So Riemann-Tiemann reaction is totally different from Kolb's reaction. You please remember that naming reaction, because there are so many questions from naming reaction only. Even for the board as well as for competitive, naming reaction, just a hand in hand, you just keep it so that it will be, you will remember ever. Okay, you'll be remembering every time. So this is phenol combined with sodium hydroxide. So you will get sodium phenoxide, you'll be getting, right? So this is ONA. So hydrogen, which is replacing that H2O, it is releases, right? H2O. So sodium phenoxide. Sodium phenoxide combined with the carbon dioxide, you know very well. So this CO2, which is connected, this is ONA, safer side. And the next one, COOH, carboxylic acid, it converts. Where is that hydrogen has come? See, hydrogen, nothing. It has come from here only, COO, and the hydrogen which is joined over there. Right now, next one, what it is? So this is combined with H plus ion. So this is combined with H plus ion, H plus. So you'll be getting what it is? Salicylic acid, that is Kolb's reaction. So here H plus, so for example, it's Cl means NaCl be released. So in that hydrogen which is replaced, so hydrogen. So NaOH, so NaCl it is releasing and H which is going to attach and here COOH. So this is 100% what it is? Salicylic acid. Okay, this is what it is? Salicylic acid. Salicylic acid. Acid. Salicylic acid, CY or CI, salicylic acid. Okay, so this is Kolb's reaction. Hope you understand this question. And come on, let us go to the next question in our next video. And I think it has taken so many days. Sorry for the inconvenience. Next videos will be very soon. You will touch. Thank you. And thanks for your valuable time you're spending and watching. And I hope you can understand these questions and the way I have explained. Thank you so much.